Hello again, everyone. So last time we added functionality for adding a node and removing a node and asking if and also adding an edge and removing an edge. And then we also asked if the network has an edge or not. And this was at the end here. We asked if the node has an edge or not. And if it does have an edge, it will return true. If not, it will return false. But now, as if you think about this, the networks that we're going to be working with this is network science. We're going to be working biological networks, social networks, all kinds of networks. So we definitely need to implement a large scale mechanism to allow us to enter a lot of data together instead of entering one node at a time or one edge at a time. It will not be scalable. So in this video here, I would like to show you how we can at least populate the network by various nodes and edges at the same time. Instead of just doing it one at a time, now we're going to be doing it from a large scale mechanism. At least I'm going to show you the implementation this time here. So let's continue. So we are going to define a function. We are going to call it add edges from. And this is a little different from add edge here because this is singular, right? And what we need to do is to pass an edge list like that. And this edge list here is supposed to have the list of all the edges that I'm hoping to use to populate the network. And let me show you here what I have in mind. We can actually have a list of this type of structure here. So this is my list, and the list would have pairs. Each pair will have a source and a destination, or source or a target, or left and right. So all of these guys are just pairs, and it goes all the way to whatever number of edges that you want to add. And remember, this is a tuple because it's a pair that has been implemented using the parentheses here, and this is a square bracket data structure, which means it's a list. So what we need to do now is to process that list here, and we're going to process it one element at a time using the for each mechanism. For each edge in the edge list, like that. And now we're going to process this edge. This edge here has two components. One is the right and one is the left. How do we get those? Well, remember, if it's a tuple, then we can access it by indices. So this is my left, and edge 1 at index 1 is my right. And I'm going to make this just a comment and make it my cheat sheet. So before I add an edge, I really want to make sure I want to add an edge that is not there, because if the edge is already there, then it's silly for me to add an edge that is already there. So what I need to do is to actually ask if the network has that edge or not. And as a matter of fact, we actually have a function here that's called has an edge. And remember, this function here is a function that belongs to our network class, which we have to access it using a self. Because it belongs to this guy. It belongs to this class object here that we're going to be instantiating. So it's coming from self. Is not function coming from the outside world. So we need to pass a self parameter here, and this self here is going to invoke has edge, because that's what we need to do. We need to say I am using the has edge that is part of this self class here. And what I need to do is to pass my left and right. And the left is going to come from the edge here that I'm processing from the list, and the right is also going to be coming from the edge here, the second component of the edge. So now we understand why I had these guys commented out, because I wanted to use them as a cheat sheet. Okay, so now I want to say if the edge is not in the network, then I want to add it. How do I say that? If I ask this way, then it's going to tell me if the edge in the network, and if it's not in the network, then I won't be able to work with it. I mean, if it is in the network, I won't be able to work with it. So what I need to do is to say if not in the network. What I need to do now is to actually add it. And as a matter of fact, we also implemented add edge as well. Add edge, and it's a self. It belongs to this class. Oopsies, like that. So I'm going to invoke add edge that belongs to the class, and add edge here takes the left and also takes the right. So as you can see, once we implement something, we can start utilizing it. Then this is really great. This is the beauty of object oriented. You design something and then you start using it all over the place, including even the class that we have not even fully finished yet. We're still utilizing some part of it to make it better and bigger. All right, so now if the edge is not there, so what is it that I need to do? I'm just gonna add. Otherwise, I'm not gonna do anything else. And at the end of this, I'm going to return the self underscore underscore the graph data structure, which is my dictionary. I don't know why I keep mistyping things. My keyboard is acting funny. Okay, so I think if we run this, let's run it and see if we committed any typographical errors. It did not seem like we've done anything wrong, which is really great. Now what we need to do is to also run our dictionary here in memory, so we can create a new network object, but let's just run it first. Now I would like to create a new network object, and let me remind you of how we created our network object. To create our network object from here, well, we have a constructor that takes 3 different parameters beside the self, and the self we don't have to worry about it. So right now we need to create a new network object, and the case is sensitive, which means the uppercase has to be uppercase and lowercase has to be lowercase. So now we're gonna call this collab network, like that, and we're gonna give it a type. It's undirected, and I don't know, my keyboard again is acting weird. And then we are going to pass the dictionary object here, the data structure, to the network, because this is the data structure that's going to represent my network. And we have to, this is gonna return back an object, and let's call it collab G, like that. And let me make sure, if I run this, I won't see anything, but if I uncomment it now, I'm going to see what's inside it. Okay, now I'm gonna run, no, I need to print the info now. Let me just print the info on collab G. I want to see what's inside it. If it's, yes, very good. So it has a name, the name that we passed. It has a type, the type undirected. It has a number of nodes because we actually entered 6 keys here. And it looks at the unique number of keys here. So everything else is repeated. So we have 6 unique keys. Very good. Now let's get back this network here, this graph here, and I'll show you. I'll explain why I'm getting that. And okay, so I'm getting back this graph from my network because I want to create a NetworkX object, and I want to visualize our network here, our collab G. So I'm getting this object here. Let me call it just NXG, like that, which is going to tell me this is my network object, a NetworkX object. And I need to import network object because it's not imported yet. NetworkX, import NetworkX as NX, like that. And I'm going to create a network object graph that is going to take my graph coming from the network here, with my graph data structure, which is essentially a dictionary. And this is gonna be NX collab G. So we just have to distinguish our graph that we called collab G versus NetworkX collab G. And why am I creating 2 different networks? Why can't I just visualize the graph that I created? Well, because I can't. my graph is not visualizable. That's why I'm actually importing NetworkX, so I can feed it with the networks that we create, so we can visualize using NetworkX. How do I visualize using NetworkX? Well, there is NX here, the handle that we use here, and we invoke the draw function like that, and it's going to take the newly created graph that is originally my graph that I created, and I still want to see the labels, so it's going to be true, and I want to do node color to be red for the time being. Let's run this. Okay, it seems, I'm not sure why it's not liking this. Okay, because I need also to prefix it by the handle here, because graph here does not belong to my environment, to my environment. It belongs to NetworkX library. So I need to prefix it by NetworkX. Okay, very good. So this is, none of this is new. The only thing that is new is adding edges from that we implemented, but we have not yet tested. But let me show you how we can test it. I would like to add an edge from D to F, and from C to D, and from C to F, and E to F. And here, I'm gonna pass it as a list. And this list has pairs. Each edge is represented as a pair, and this pair is actually implemented as a tuple data structure in Python. So if I run this like that, then I'm going to see that the new edges that I created here that I'm supposed to be adding are already here. Okay, so as you can see, I want to add an edge from C to D, right, and C to E like that, and I want to create from D to F right here, and from E to F. So how many edges do we have? 1, 2, 3, 4, 5, 6. So by adding 4, my network should actually have 4 of those. Okay, how do I call my function? And how do I see that I'm indeed going to add the edges? Okay, well, we're gonna call it. Here's how we're gonna call it. Let me just kill all the stuff that I had earlier. I'm sorry. Okay, one last, like that. So now let's try to call this function here, the add edges from. And remember, add edges from belongs to our graph that we created, which is called collab G. So this is exactly what I'm calling it against. Okay, and collab G takes self if it's inside the class. Outside the class, we don't pass the self anymore. But we need to pass the new edges that we said that we want to add them to this guy here. Here's my new edges, like that. And this is supposed to be giving me a new dictionary. Graph after added edges, like that. If we did everything right, this is supposed to be giving us, okay, so this graph here, if we print it, is going to show us that we added interesting things. So let me see, it added, we said we want to add from C to E, so it added from C to E and added also from C to D, very good. So it added these two guys, fantastic. And let's also see what else did it add, because we also said we want to add from D to F, from D to F, very good. So F is here already added. And we also said we want to add from F to E, from F to E. And remember, this is an undirected graph, so if we add from F to E, it goes ahead and also adds it from E to F. Remember, we did this in the implementation here. When we added the edge, we wanted to do it from left to right and right to left. In a directed network, then we have to stick with the order. But in an undirected network, we have to add it from right to left and left to right. It seems to me like this object here is looking much different than this object here. And let me prove it to you, if I can. Okay, and as you can see, so when we invoked add edges from, we invoked it on our collab.g, which is a network object that we just implemented together. Okay, so we were able to add this guy here. How do we now? I want to see if we can visualize the network that looks something that is much more complex than this one here. I want to see these 4 edges being added to the network. How do we do this? Okay, well, let me just copy this for the sake of making quicker progress. I am going to create a new graph, new NetworkX graph, and I want to pass this graph that we created here, the graph that we populated after we added. So here's what we're gonna do. We're gonna pass the edges, and this is my NetworkX collaboration. Okay, so it's different from what we call collab.g, which is coming from our network class, but NX here, NXG, and let's call this P for populated, or maybe appended with the letter A, because I also see that we created NXG collab here. So let's not collide with any naming convention. So this is now the NetworkX object that we are going to visualize, and I'm going to pass it here. And let's see if we've done everything right. We should have a really nice network. As you can see, indeed, we have C to E and C to A and C to D. What did we say? Let me copy this so we can actually compare. Like that. Let me go back here. I'm gonna kill these guys because they're just annoying. Let's check if we actually have C to D. Do we have C to D? Where is C? We have C, D. Very good. Do we have C to E? C, E. Oops. C to E. Very good. Do we have D and F? Where is D? And where is F? Very good. Very good. Do we have E and F? Where is E and F? Fantastic. If we count those, so we actually had, let me count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly 10 number of edges. And actually, here's what we can do also, because we created a NetworkX object. A NetworkX object can give us the info on this graph because it's fully implemented. Info like that. I'm sorry, NetworkX has an nx.info, and then info takes the graph object. Remember, this is not the info function that we implemented here. This is not this function here. Where is it? I am not invoking this one. I am invoking the one that is built inside NetworkX. Why? Because we actually did not include the number of edges. So I just want to be sure that if we do this, we're going to see the exact number of edges that we have not implemented yet in our info function. As you can see, it is indeed 10 edges like that. And these 10 edges are different from what we saw here. We only saw 1, 2, 3, 4, 5, 6 edges. So by now adding new edges like that from a list, then we're having a great deal of success. You might still want to say, well, okay, well, this is great that I'm able to add things from a list, but still hard coded in a program. I will have to agree with you on that. I would say yes, it is hard coded, but watch the next lecture, and I'm going to show you how we can actually create a network using our implementation, this implementation here. And we're going to create a network that is coming from the Twitter sphere, from real data, and this data is going to be converted into a list that looks like this, and we are going to pass that list to our object, and then we're going to get a much more complex network than what you're looking at right now. Okay, so again, if you happen to have any questions, write me a comment, shoot me an email, and let me know how you're feeling about the implementation. If this is too technical for you, or you just want to work with the data. Any feedback would be really helpful for me, so I can start catering things that are much more helpful to the majority of the audience. But I like the way that we actually implement things, because it makes you understand how networks work. We can call things from NetworkX. As you can see, they are already there implemented in NetworkX. But as we are implementing them here in our Python class using object-oriented, we're gaining a lot of insights. We see how the networks are constructed. We see how the networks are implemented. We see the operations that we actually need as part of the network, so we can start working with those. So enough of that. Just like I said, let me know if you have any questions, and thanks again for watching.